If you have any questions, you can email them to me at swartwoodprep@gmail.com. Just address them to Danielle on YouTube.
So hey guys, we've had a couple of requests for a Math 3A review. The problem is that since the board is being more strict, mostly because MCAT and DAT are getting so big, they want to limit the reviews I do to the most popular. So those first two midterm rounds, Math 3A didn't make the cut, sorry about that. But we're trying to do a live one for the final exam review. And for those of you that had questions about earlier stuff, I'm going to do some topics now. So if you don't know, let me make sure this problem's clear since I'm shorthanding this. So, got two guys starting off together. One goes to the right at 300 meters per second, the other goes straight south, right, or straight down at 400 meters per second. They start at the same point. After 3 seconds have passed, what is the rate of change in their distance, the direct distance between them as they're moving along? Okay? So, what is the rate of change of this distance between them when exactly 3 seconds have passed? Okay, so that looks my constant part, the part I'm going to plug in at the end, just like we did for the previous problem. So let's put that here. So I want to know what happens at 3 seconds. No big deal. Let's translate just like we did before. So they want the rate of change of the distance, I guess, with respect to time, right? So I need a name for that. Can I call it D? Is that okay? I know that might be a little confusing, but can I call this can I call the distance big D? So what we're looking for is the rate of change of big D with respect to time. That's what I'm trying to figure out, right? So let's put that up here. So I want the rate of change of big D. What else have they given me? Well, they're giving me this. By the way, since this might look a little confusing, let's draw this out. Is that okay? Can I call this guy X? Can I call this guy? If that bugs you, we can make this positive in the X direction and this negative in the Y direction. It won't really matter because we're computing a distance. Okay? What do I know? So I know the rate of change in the X direction. So that would be the change in X or change in time. That's what they're telling me, right? And it matches too. X is in meters, time is in seconds. Should be 300. Okay, no big deal. Okay, let's look at the rate of change in the Y direction. The rate of change in the Y direction, so again, the way I picked this, you can pick it any way you want. We made down negative. That should be negative 400, right? No big deal. Okay, that's set up. So again, we've translated to this. Okay, so maybe CAD logic, my bad. dx dt is 300. dy dt is negative 400. Okay. Now what am I trying to go for? What I'm trying to go for is something like this. I'm trying to figure out what is the rate of change of the distance between them. So again, I need a linking formula. And I can think of it as a non-calculus linking formula. So if you took the calculus out of it, so you're not taking a derivative with respect to anything, and you're looking at y, x, and d, what's the relationship? So that goes back to basic geometry, right? And the relationship is, if this is my x, and this is my y, right? And this is a right angle between them, because he's going straight to the right and straight down, then this length here, this d, it's connected by Pythagorean, right? So the relationship is x squared plus y squared is d squared. You do not have to solve for d in order to get the basic equation to manipulate, because we're just interested in the derivatives. So this relationship is fine. You don't have to write this as d is equal to the square root. You can if you want, but any setup is fine. I just need to link these guys in some way, and that does it, right? Okay, so let's start with that. So there's my defining relationship. It's non-calculus based. D squared is x squared plus y squared, right? Doing the Pythagorean theorem. Okay. Now I want to translate this back to things that look like derivatives. But again, it's easy. I'm going to take the derivative, right? With respect to who? So distance with respect to time, x with respect to time, y with respect to time. It's got to be with respect to t, right? Okay, so let's do that. So what is the derivative of these guys? Remember, they're now all boxes because the independent variable is time, right? So take the derivative of box squared. That's 2 times the box to the first power, right? But chain rule times the derivative of the box. Remember, the independent variable is t, super important. So that would be dx dt. Okay? Okay, now let's work this out. Plus, let's take the derivative of this guy with respect to time. So that's going to be something like 2 times the derivative, 2, the box to the first power, times the derivative of the box, which is again, dy dt. Right? And then don't forget the final guy. So what is this? 2 times the box, right? Times the derivative of the box, which is dd. That sounds weird, over dt. So this is my equation linking derivatives. Do you guys agree? Okay. So if you're okay with this, let me clean this up a little bit so you get some room. And just to make life easier, I want to divide everything by 2. Divide, divide, divide. Okay. So now we get something like x dx dt plus y dy dt is equal to d, I guess, dd dt. Okay. So everything looks good so far. I can plug in some of these numbers. So like for x, we can get 300, well, not x, but dx, we can plug in 300, right? dx dt, sorry. So dx dt is 300, no big deal. Y times dy dt, dy dt was negative 400. Don't worry, it's not going to be an issue. The sign will work out just right. And then d, dd dt. But this is the guy I wanted to solve for, right? Okay. So unlike the previous problem, well, actually, kind of like the previous problem, we have everything set up nicely. We have our unknown, right? But now we need to plug in. Okay? Unlike the previous problem, there was only one guy you need to plug in, and they just gave it to you. Here, even though it's coded, they must give you these other guys, otherwise you can't solve this equation, right? It looks like they don't, because all they gave us was at 3 seconds. But my claim is, if you know that you're at 3 seconds, you can figure out all of these guys. In fact, let's just do it. If at time 0 you're at x position 0, and you go at a rate, so remember distance is rate times time, and you're going at a rate of 300 meters per second, and you've gone for 3 seconds, then you can solve, and by the way, just so this isn't confusing, I'm using the general formula distance is rate times time, but the distance I'm actually measuring is not this distance, it's just the x direction, right? So I'm going to call it x, right? So the x ground that you've covered is 900. No big deal, positive 900. So better plug in here. So this x is positive 900. Okay. And then let's plug in for this y. Okay, same thing. So remember, the basic form is distance is rate times time. So how far you've covered y should be the rate, which is negative 400, right? dy dt was negative 400, times the time, and you were told how much time elapsed? 3 seconds. So y should be negative 1200, right? No big deal. So here it's negative 1200 times negative 400, right? Plugging in for y, keeping this the same. Almost done with this. So now the final part. I need to solve for d. But d2 we can solve for, right? Again, there is no direct formula giving d because d is this distance, right? This is my distance d. Everybody agree? But again, I'm still getting that same triangle. So this is all really about the Pythagorean theorem. So if I clean this up, let's see what we've got. If I want to compute d, right? Then I know what the picture looks like. At this point in time, x is 900. At this point in time, y is negative 1200. And I'm trying to figure out what this d is. But I can use Pythagorean. So it's true again that 900 squared plus negative 1200 squared is equal to d squared. So I computed this number and took the square root to get d. You would get the same answer. d happens to be 1500. Okay. No big deal. So now I plug back in. 1500 times d dt. This is my target, right? So after this, there's nothing left for you to do but crunch the numbers. Okay? And it'll be pretty nice. So give me a second for this. Let me take this away. Okay. And then we would crunch these numbers. Again, the arithmetic doesn't matter. You can just plug into your calculator. That's not the point here. In fact, I could have been smart, and divided everything by 3 to begin with. But whatever. I'll take these out like this. I'll take this, divide by 15, divide by 15 on the right, divide by 15 on the left, and get 500 dt. Wow, that actually turned out pretty pretty. So the rate of change of distance with respect to time after 3 seconds is 500. If you wanted the units, you could keep track of the units, or you could just do this as cheaply as possible. Distance over time, that must be meters over seconds. 500 meters per second. So not too bad, right?
Now I get it.